Lecture 16. Sorry, we have to do 2 lectures today because July 4th is a holiday. So my background might be noisy. Let me close my door. So those are radical equations. So radical equations. So we want to solve for the variable x. Remember the term radical means this, right? We have something, let's call it x, raised by n, this is the power n, and then with the index m. So this is called a radicals. All right, m here means index. Let's remember, what does this mean? If I have y, right, with the index m, that equals some k, equivalently, that means k raised by m equals the y. Okay, so this is the meaning of this. So sometimes I read as mth root of y. Okay, so this m is the index. This is the meaning of it. All right. Let's say A. I want to change my color to be blue. Let's say A. So we have a square root of 4x plus 1 equals 1. So what do we want to do? We're solving this equation. We want to get rid of this square root sign. But when we solve equations, we always try to get rid of something, like in the way to solve for x for the variable. The variable is x right here. So we will square this. We'll square both sides. So let's see why we do this. If we have square root of x, right, then we square this. So by default, the number here, the index here is 2. And this equals to square the x inside, then square root with index. And in both cases, this means x can raise by a rational exponent, which is 2 over 2. The numerator 2 is the power 2 here. The denominator 2 is the index 2 here. So 2 divided by 2, of course, we know that's x raised by, that's 1. That's x raised by 1. But usually we don't write x raised by 1. We just ignore the 1. We write as x. So let's see another example. If I have a cubic root of x, if I raise this one by square, I wouldn't be able to get rid of the cubic root sign. Why? Because this is x raised by 2 over 3. But I want to get something divided itself. I want to get 3 over 3. So instead of raised by 2, I raise by 3. Because 3 divided by 3, that's 1. So I get x. So basically, that's how we get rid of these radical signs. So in general, if we have m's root of x, we want to raise this by m's power, because that's x raised by m over m, that's x. All right, so let's say A by default, the index is 2. So that's why we raise by square. Once we raise by square, we get a 4x plus 1 raised by 2 over 2. The numerator 2 comes from this 2. The denominator 2 comes from this index 2. Equals the 1 square, of course, is 1. And 2 over 2 is just 1. So we just get a 4x plus 1 raised by 1 equals to 1. Again, we don't bother, raised by 1 just itself. So we can ignore this 1 here. So that's 4x plus 1 equals to 1. Then we move past the 1 to the other side, becomes negative. So we have 4x equals to 1 minus 1, which is 0. Divide by 4 on both sides. So we get x equals to 0 divided by 4, of course, is 0. So the solution for the first one is 0. If we plug in 0 for x, indeed, 4 times 0 is 0, 0 plus 1 is 1, square root of 1 is 1. Now let's see. I need to clean the space. So, oh, no, let's do B. I haven't done, let's do B. So B will have square root on each side. So we do the same thing. Square this side, we square this side. Then the left-hand side becomes 2x plus 8. The right-hand side becomes 4x minus 10. Right. Then we need to combine like terms. So we have 2x here, 4x here. We want to move around. So maybe we move 2x to the other side, becomes negative. Yes?
Are you okay in here? It's gonna be really hot.
No, it's okay. I'm recording. Yeah. Sorry. So 2x, so right, so positive, so so no sign here, that means it's positive by default. Right, so positive 2x move to the other side becomes negative 2x. At the same time, we're gonna move negative 10 to the other side, become positive. So the right-hand side will have 10 plus 8. I mean the left-hand side. The right-hand side will have 4x minus 2x. 4x minus 2x, that's 2x. 10 plus 8, that's 18. Divided by 2 on both sides, x equals to 9, because 18 divided by 2, that's 9. So this case, x equals to 9. If we plug in 9, so we see 2 times 9, that's 18. 18 plus 8, we get 26. And this side will have 4 times 9, which is 36. 36 minus 10, indeed, 26 also, right? So 9 is the solution. Let's see C. C, the index is 3. So we don't raise by 2, we're going to raise by 3 on both sides. Then 3 over 3 becomes 1. So we just get a 2x plus 7. 3 raised by 3. Negative 1 raised by 3 is a negative 1. Because negative 1 raised by an odd number stays negative 1. 3 divided by 3 is 1. So I have a 2x plus 7. Raised by 1. We don't need to really to write it raised by 1. Then move positive 7 to the other side, becomes a negative 7. So we have 2x equals to negative 1 minus 7, that's minus 8. Then we divide by 2 on both sides, negative 8 divided by 2, negative 4. We can try 2 times negative 4, negative 8. Negative 8 plus 7, indeed, negative 1. Negative 1 cubic root is negative 1. Now let's see D. D, we have plus 2 here. So we need to square both sides twice, right? Because when we square left-hand side, we get x plus 3. But when we square right-hand side, remember a plus b squared, we get 3 terms. Get a squared plus 2 times ab plus b squared. So I have this middle term. So let's treat this one as a. Let's treat this one as b. So we have a plus b. So I have a squared, which is square root of x minus 5 squared. Well, just x minus 5. Plus 2 times square root of x minus 5 and times this 2, b. Then plus b squared, 2 squared, which is a 4. Okay, so we have x on the positive x on the left-hand side, positive x on the right-hand side, they cancel out, or you can move x to the other side, becomes negative. X minus x, x is 0. Negative 5 plus 4, negative 1, move to the other side, become positive. So 1 plus 3 on the left-hand side. We have 2 times 2, which is a 4. Radical x minus 5 on the right-hand side. So 1 plus 3 is 4. So 4 equals to 4 times square root of x minus 5. Well, let's simplify this equation. Let's divide by 4. Divide by 4, the left-hand side will have 4 over 4, which is 1. The right-hand side will have this cancel each other, so we only have 1 times square root of x minus 5. Now we need to square both sides again. 1 square is 1. X minus 5 square root of x minus 5 square is x minus 5. Negative 5 on the right-hand side move to the left-hand side, become positive. So x equals to 6. Well, let's check. 6 plus 3 is 9. Square root of 9 is 3. On the right-hand side, 6 minus 5 is 1. Square root of 1 is 1. 1 plus 2, indeed, is also 3. Okay, let's see 2. We're getting into something called imaginary numbers. Let me write here. Imaginary numbers. Number system, actually. Only because this I equals to square root of negative 1. I squared is negative 1. Right? Very important. I equals square root of negative 1. Now, before we would see square root of negative 16 does not exist in real number system. But now we extend the real number system to imaginary number system. So then we have a plus b I indicates the imaginary part. So we have a real part plus imaginary part, and then we call this system complex. Complex number system. It's 2-dimension number because we have a real part, we have an imaginary part. It's a 2-dimensional number. So now, so square root of negative 16 exists in complex number system because we can write this as the square root of negative 1 times square root of 16. And square root of negative 1 is defined as I. So it's just I. And the square root of 16 is 4. We can write as 4i, or some people prefer to write I before the number I4, which is fine. Doesn't matter which one. Similarly, for this one, we can write square root of negative 1 multiplied by square root of 13. Square root of negative 1 is I. It's I square root of 13. Or square root 13i. And we can add two complex numbers. How do we add? We add the real with real, the imaginary with the imaginary. It's like adding like terms. 3 plus 4 is 7. 5i minus 7i, that's negative 2i. B, we can multiply 3i to 4 to negative 6i, which means 3i is a common factor of 4 and negative 6i. 3i times 4, that's 12i. Then minus 3 times negative 6, that's negative 18. I times I will have I squared. And we cannot stop here because we know I squared. I squared is negative 1. So we have negative 18 times negative 1, 12i. Negative 18 times negative 1, that's positive 18. So we'd like to write, so it's real part. We write the real part first. Then plus 12i, right? By default, no sign, that means the plus. Now let's see C. C, we have 2 terms, multiplied by 2 terms. So we FOIL. First times first, second times second, second times first, first times second. 3 times 5, 15. I times negative 3i. Let's do this on the side. I times negative 3i. It's negative 3i squared, but the I squared is negative 1. So negative 1 times negative 3 becomes positive 3. So we add a 3. Then I times 5, 5i. 3 times negative 3i, negative 9i. Add those two, get negative 4i. 15 plus 3, that's 18. So multiply those two numbers, we get 18 minus 4i. So you see, we add complex number, we subtract complex number, we multiply by complex number, we end up with complex number. Now let's say D. D is a little bit tricky. D cannot do square root of -9 times -4, then become positive 36, then become 6. No, this is wrong. Okay, we cannot do that. So what do? We need to change each one in complex number form, because square root of -9 is a 3i. And square root of -4 is 2i. 3i times 2i is 6i squared. Well, I squared is -1, so that's -6. Okay, so be very careful with the D. Let's see, 4. So question 4, we want to divide. So with the complex numbers, we can divide them, multiply them, add them, subtract them. So this one we want to divide. So this means 4 divided by 2i plus 3i divided by 2i. Well, I divided by I becomes 1. So this one was just left with 3/2, which is the real part of this one. So 3/2, let's write on the side. Then, so this is done. Then we have 4 divided by 2i. So how do we deal with that one? We don't want to let I stay in the denominator. So we would multiply I over I, which is 1. We can always multiply by 1. And then we get 4i in the numerator. Denominator with 2 times I, 2i squared, which is I squared is -1, so we get -2 in the denominator, 4i. Then 4 divided by -2, still -2, so we still get -2i. So the result for A is real part is 3/2, the imaginary part is -2i. Now let's see B. B, how do we divide by this? We want to multiply by the conjugate, which is 5 plus 3i. Difference of two squares, right? We have A plus B times A minus B. That equals A squared minus B squared. So of course, we need to multiply by the same thing for the numerator. Then the denominator by the formula, we get the first one squared, 5 squared, minus 3i squared, 3i squared. The numerator, let's leave the numerator. Let's do the denominator for now. 5 squared is 25, minus 3i squared. Well, let's do 3i squared on the side. So that's 3i times 3i, which is 9i squared, which is -9. So 25 minus -9 becomes 25, negative becomes plus 9. So the denominator becomes 34. But now let's see the numerator. 1 times 5, that's 5. I times 3i, -3. The middle term is 5i plus 3i, which is the 8i. And 5 minus 3, which is 2. So the numerator is 2 plus 8i. 2 plus 8i. Now we need to split it into the standard form, a plus bi form. So 2 divided by 34 plus a divided by 34i. 2 divided by 34, we can divide by 2 in the numerator, in the denominator, so we get a 1/17. Similarly, for the second one, we divide by 2/2, so that becomes 4/17i. So this is I. So the real part is 1/17. The imaginary part is 4/17. let's see 5. So I actually is a cyclic, So I is square root of 1. I squared is a rational number, -1. I cube is a negative I to the 4th power becomes I squared times I squared, which is a -1 times -1, +1. So I is a cyclic of 4. Right? Cyclic of 4. So what do we want to do with this? We want to split this as I raised by 20 times I. I raised by 20 is I raised by 4, then raised by 5. Because I raised by 4 is 1, so 1 raised by 5 times I. Well, 1 raised by 5 is 1. And 1 times I is I. So this one is the same as I. 34, we want to split as I raised by 32 times I squared. Because I raised by 32 can be split as I raised by 4, then raised by 8. Then multiply by I squared, which is -1. I raised by 4 is 1. 1 raised by 8, still 1. Times -1. So we just get -1. So in the end, this is just -1. Because I is a cyclic. Okay, I think that's everything for 17. Let's see. Yeah, that's it. So tomorrow we're gonna do 17 and 18. Yeah, see you tomorrow.